My name is Aarti Goel. So today I am going to discuss normalization. So the outline of this lecture is, first we'll discuss the functional dependencies, then we'll discuss the closure of a set, how to find the closure of a set, different kinds of keys, candidate key, primary key, super key, non-key, prime key, and so on. Then the normal forms, why we need to reduce this, why we need this normalization, first normal form, second normal form, third normal form, BCNF, and so on. So first understand this functional dependency. So basically this allows us to express the constraints, whatever constraints we have for the attributes. So suppose R is the relational schema and A tends to beta, alpha tends to beta. So this is a FD. Now here alpha and beta, this alpha and beta, they are the subset of this relation R. R is the relation schema. So this holds on R. R is the name of this relational schema. We have alpha, beta, and tuples. So tuples are, okay, now please understand this, tuples T1 and T2, right? This holds if and only if for any relation two tuples T1 and T2 of R agree on the attributes alpha and they agree on the attributes beta. So that means T1 of alpha equals to T2 of alpha. This implies T1 of beta equals to T2 of beta. And this FD functional dependency, they determines the unique value for the another set of attributes. So for example, students and instructors, they are uniquely identified by their ID, identity. Each student and instructor has only one name, and each instructor and student is associated with primarily one department. So to understand the normalization, we should know how to find out the closure of a set, closure of a functional dependency. So we will be given some functional dependency and that is logically implied by the F. So here A tends to B is one functional dependency, B tends to C is another functional dependency, and we can refer A implies C. So the set of all functional dependencies logically implied is the closure of F. So it is represented by F dash. If I need to find out the closure for this, F plus, it is represented by F plus. So the closure will be closure A implies B and B implies C. So this way closure can be found. Now let's understand the different or the various types of keys that are used. So the first one is the super key. We have the multiple attributes or the columns, and super key can be more than one and it uniquely identifies the rows in a table. So next is the minimal of the super key, that is also known as the candidate key, and with no redundant attribute. So that is a candidate key. They can be also more than one. Then comes the primary key. It is a column or the set of columns that uniquely identify the tuples in that table. So, or we can understand it as we have the super key. Super key. The subset of the super key is the candidate key, and the subset of the candidate key is the primary key. So we can understand in this way also. Then we have this alternate key. So out of the candidate key, there will be only one primary key. So rest of the keys will be known as the secondary keys or the alternate keys. And if the key consists of more than one attribute, for example, name. For the name, we have the that can be decomposed into more than one attribute. We can decompose it to the first name, middle name, last name. So this is a composite key that uniquely identifies rows, and the foreign key is the column of a table that points the primary key of another table. So that is basically used for the cross reference between the tables. So this I have already discussed. Primary key is the subset of candidate key, and candidate key is the subset of super key. Now coming to the today's topic, that is the normalization. So normalization is used to reduce the redundancy. So we have the redundancy or the duplicate data in our tables, in our database, and we need to identify it and reduce it. That is the normalization. So what are the problems with this redundancy? First, redundant storage. If we'll store the data in multiple files, multiple folders, then in multiple tables, then of course the information will be stored repeatedly. Then update anomaly. It will be very difficult and inconsistent to update the new or repeat the data in everywhere. Insertion anomaly. It may not be possible to store some information unless some other information is stored. Deletion anomaly. So these are the different problems that are caused because of this redundancy. So we will be discussing first normal form, second normal form, third normal form, BCNF. They are basically based on the single value functional dependency. And then fourth normal form, fifth normal form, they are based on the multi-valued functional dependency. So maximum redundancy is in first normal form. That will be in first normal form, and for a relation is said to be in a particular normal form if it satisfies a certain prescribed set of conditions. So suppose relation is in second normal form, then it means it is in first normal form. If the relation is in third normal form, then it is in second normal form. We'll discuss more in this. So this is the diagrammatical representation of various normal forms. First normal form is the first normal form, then second normal form, then we have third. So we can say if the functional dependency, if it is in second normal form, then it must be in first normal form. So because second normal form is the subset of first normal form. So let's start with the first normal form. So a relation R is in first normal form if the domain of all the attributes are atomic. All the attributes, all the columns, the values for them should be single value, and this R should not contain the multi-value attribute. There should be a single value for a single attribute. So for example, the non-atomic domains are set of name. Name can be decomposed. It's a composite attribute. Or the identification number, for example CS101. So this can be broken into two parts. One is the department code, that is CS, and another is the serial number 101. Then second is the second normal form. In second normal form, relation R is in second normal form if and only if R should be in first normal form. This is the first condition, and then we need to check R should not contain any partial dependency. There should not be any partial dependency. So we need to understand first what is this partial dependency. So the proper subset of candidate key should not imply any non-key attribute. That should not derive any non-key attribute. So let's take this example and try to find out the highest normal form for this functional dependency, for this relation schema. So we have the relational schema A, B, C, D, E, F. These are the attributes. FD is given functional dependency. AB implies C, C implies D, B implies E, B implies E, E implies F, and we need to find the highest normal form. So for this kind of questions, first we need to find out the candidate key or the closure of the set. So for this, let's find out the closure. If I find the closure of A derives single A attribute, cannot derive any other attribute, cannot derive, right? So we can try for the combinations as well. If I try for, let's try for B, closure of B, it comes out to be B, and B can derive E, and E can derive F. That's all. So all the attributes are not covered in this closure set. So we can try the combination as well, right? So if I go for closure of AB, if I try this closure of AB, AB can derive C, C can derive D, this B I have already covered, so this B can derive E, now E can derive F. So if I check all the attributes A, B, C, D, E, F are covered using the closure set of AB. So we can say AB is the candidate key. So there can be more than one candidate key. We can find out, we can try more combinations. So if I try some other combination, let's try AC. The purpose is to cover all the attributes. That is the purpose. So if I go for AC, now C can derive D. What else? We do not have B, we do not have E. So ACD, that is the closure of AC, right? So in this way, if you will go and try for all the combinations, you will find there is a single candidate key, that is AB. So the candidate key is AB, and if we are able to determine the candidate key, then we can say the given relation schema is in first normal form. So this implies the relation is in first normal form. Now we need to check for the second normal form. For the second normal form, we need to check that there should not be any partial dependency. Partial dependency should not be there. So for this, we need to find out the prime attributes, I mean the key attributes and non-key attributes. So this is the only candidate key, that therefore this AB will be the primary key. So this will be the primary key, and all the attributes of the primary key or the candidate key are the prime attributes. So AB, so prime attributes are AB, A and B, they are the prime attributes. Right? Now we need to find out the proper subset of candidate key. Now that we have the proper subsets, A is a proper subset of candidate key, B is the proper subset of candidate key. They should not determine the non-key attribute. So we have AB. AB is a candidate key, that is not a proper subset. C, that is not a proper subset. B is a proper subset. So please check this. B implies E. B is a proper subset of candidate key and it implies E, and E is a non-prime attribute or non-key attribute. So this is there exists a partial dependency. Therefore, we can say then this given relational schema is not in second normal form. So the answer to this question is the highest normal form is first normal form. Okay. Or you can understand the remaining of those who are not the prime attributes, the rest remaining are the non-key attributes. So the non-key attributes are C, D and E. Let's take one more question. Our relational schema, we have A, B, C, D, E, F and G. They are the attributes. Functional dependency, AB implies C, C implies D, A implies E, B implies F, E implies G, and we need to find the highest normal form. So let's try this. First, we need to find the closure set so that we can determine the candidate key. So let's try the different combinations. So if I try for the single attributes and try to find out the closure, so if I go for A, so the closure of A will be A, and A derives E, E, and E derives G, so G will be there. Rest of the attributes cannot be determined. So similarly, we can try for B, C, and we'll find that we cannot determine all the attributes using a single attribute. So we'll try for the combinations. We'll go for the combinations. Try AB, closure of AB. So AB determines C, C implies D, A implies E, B implies, B is already there, so B implies F, E is already there, E implies G. And if you compare this with the given relational schema, then all the attributes are covered, A, B, C, D, E, F, G. So we have 7 attributes and all are covered using AB or finding the closure of AB. So we can say the given relation is in first normal form. Now we need to check for the second normal form, then third normal form, and so on. So let's try. The prime attributes will be A and B. Non-key attributes or non-prime attributes, they are C, D, E, F and G, right? So we have the A and B. Now let's check proper subset. Proper subset of condition is proper subset of candidate key should not determine non-key attribute. This is the condition, this is not allowed, this is the partial dependency, right? So there should not be any partial dependency. So we are going to check proper subset of candidate key, that means A or B. So we have these two FDs, A and B. So they should not determine any non-key attribute. So A implies or A determines E, and E is a non-key attribute. E is a non-key attribute, right? Similarly, B is a prime attribute and this determines a non-key attribute, F, right? So there is a partial dependency, A to E and B to F. So this given relation is not in second normal form, not in second normal form. So the highest normal form is first normal form. So I hope you understand this. Now come to the third normal form. So our relational schema R is in third normal form if R should be in, so the first condition is it should be in second normal form and non-key attribute should not transitively determined by the super key or candidate key. So we'll understand this point, B point. This says the non-key attribute should not determine non-key attribute. Now please understand this with the help of example. We have the relational schema A, B, C, D, E. AB tends to CD, D tends to A and C tends to E. And we need to first check whether this is in second normal form or not. And if it is in second normal form, we need to check whether this is in third normal form or not, right? So first step is to find out the candidate key. So let's try the different combinations. If I go for closure of AB, so AB can determine CD. Now we have D. D can determine A. A is already there. C determines E. C can determine E. If you will compare, we have covered all the attributes. Try another. Let's take this BD. BD is the second. So we can directly take this BD, right? Or you can try the different combinations later. So BD can determine, D can determine A. Now we have A and B both. So both can determine CD. D is already there. And C is there. So C can determine E. Right? So this given relation is in first normal form. This is in first normal form. Then the key attributes are A, B and D. And rest of the attributes are non-key attributes. So non-key attributes are C and E. They are the non-key attributes. So we check for the partial dependency where whether there is a partial dependency or not. So let's check for the partial dependency. So the AB, proper subset of AB is A and B. Proper subset of BD is B and D. So D determines A and A is also a proper subset. C determines E and C is not the prime key. So partial dependency is not there. We can say the given relation is in second normal form, right? No partial dependency exists. Now let's check for the third normal form. So for the third normal form, we need to check the non-key attribute should not determine non-key attribute. So here in this we have C implies E. C is and E, they both are the non-key attributes, and non-key attribute determines the another non-key attribute. So this violates the condition for the third normal form, and therefore we can say that the given relation schema is in second normal form, not in the third normal form. That is in highest normal form is second normal form. Thank you.